So hey guys, welcome back to another video of SPF Tutoring. Today we are going to learn about long division. Not the normal long division, but the grade 12 advanced function long division. So here we have a easy equation just to learn about how to do it. So we have 2x squared plus 3x plus 1 divided by x plus 1. Right here we have this, our numerator is our dividend, and our denominator is the divisor. You don't really need to remind these terms, but just to know that what is what, because sometimes they will provide it in a word problem, something like that, so it may help you somewhere. So let's solve this. So first we'll do our normal box. Oops. So normal, not the square root, but our dividend symbol, whatever you want to call. And then we'll put our dividend here. That's 2x squared plus 3x plus 1. And our divisor, which go here, will be just x plus 1. Now, our whole aim is to divide. So when you do this long division with the equations, what you mainly aim is to get rid of the first variable every single time. So how it basically works is, so now you have this whole thing, all right, and then you have this. Okay, so now something multiply this by x should give us 2x squared. Okay, normally how we do is, like normal division, there's this 8, you divide by 2. What's multiplied by 2 to get 8? You put 4. Same thing, we want to get 2x squared up here. So how we basically do it, we already have x, right? So how you think actually is 2x times something equals 2x squared, right? You would say you divide both sides by x, and this get rid, because this is power 1, and just get rid of 1x. So now the question mark is basically 2x. So that's how you put 2x up here. So now 2x times x gives us x squared. But this is a whole equation, right? An equation. So you also multiply 2x with 1 as well. So 2x times positive 1 is just 2x. So you do positive 2x. But here's some catch. If you remember, when you do this, 4, that comes 8, and we put a minus subtraction sign up there, and then we aim it to 0, right? Same thing will go up here. But for that, we need to bracket this whole thing and then put a negative sign, basically. So negative sign will convert this positive into negative, and this positive to also negative. So in turn, now we have negative 2x squared minus 2x. So now this is negative and this is positive, so this whole cuts. Then this will go 0. You really don't need to put 0, but we'll just put it 0 for now. And then you have to keep in mind that it's negative 2x now, because you multiply the negative with positive 2x. And it's like, why are you doing negative times positive 2x? That really never works. There's just imaginary 1 up here that makes it negative, because now it works, right? Negative 1 times positive 2x is negative 2x. So negative 2x, and you have a positive 3x. That's x, greater sign, positive. So just positive x, and then you drop this one, which is positive 1. And now, if you see, both things are the same thing, right? Then what times this gives you x plus 1? Basically, just 1. So it would be just positive 1. And now, if you're thinking, like, how are we supposed to know that this will be positive or negative? Because sometimes the equation will be, this can be a negative sign, and then this, you already have a negative. Do we put a negative or not? Technically, you don't. You just take this, you just do it by yourself, right? You do normal multiplication, and then you just put a negative sign. It doesn't matter what things changes up. I'll explain this. It will be much better if I show an example. The next example will be something like that. So for now, back to the topic. X plus 1 times what gives us x plus 1? Basically just 1, and we just put x plus 1, right? And don't forget to put the negative sign. So we bracket it, we put negative. This is negative, and that also become negative. That basically gives you 0. This 0 is basically a reminder. And this is our quotient. Okay. If you know what actually we should not go up there. So let's do another example where I was talking about a negative sign up there. So the next example is x x cubed minus 4x plus 4 bracket divided, like that doesn't sound like divided, but divided by negative x plus 2. So you would think, why we have negative sign up there. There's a bunch of ways you could solve this equation. I mean, you solve this using long division. Is like you would change this up, or you could also say this is this, and you solve it, but it makes it really complex, and we don't really need to do it right now. So we'll just do normal division like we did it for the first example. So we set this x cubed minus 4x plus 4 negative x plus 2. Okay, same ideology up here. What times x gives us x cubed, right? Now the things really comes to a little bit complex, but okay. So you have been thinking, right, this is just x squared, and that would be x cubed, but here's a negative sign, so this would be negative x. And then we put x squared times what we normally do. X squared times 2 is positive 2x squared. And then you would put a negative, because we never forget about negative. Then we think this become positive, this become negative. You can't subtract the one exponent variable with it twice. That's something we never learned. But no, really, actually. So you don't solve like this, like you would normally do. So what you do is, because here there's a missing term, which is 0x squared, right? Because if it's 0x squared, you would remove it, because 0 times anything number becomes 0. So you remove, so there's an extra term up here. So the real division is basically x squared plus 0x squared. When you think, why would plus, why would negative? It really doesn't matter if it's negative or positive. 0, we don't really, it doesn't matter if you put negative 0 or positive 0, it's still 0. So that would be this divided by negative x plus 2. It would be still negative x plus 2 because we want it to be as it is. Now this is our new basic question or term, whatever you want to say. So now you put, so this is our basically the actual how you have to do it, because then the conflict what I saw you would occur. So now this works, right? So we would do the same thing. What times x would give you the x cubed? We would say x cubed, and here it would be x cubed. And like, oh, it's a negative, but we want it to be positive, because when we do a bracket, then it only would become negative. That's why what you do is always remember that whatever is this sign up here will go here. So if it's negative, the negative has to go here. I mean, opposite side, never mind. So whatever this sign is, has to go this sign. It will only work if it's positive, because then only the subtraction line would come in and it would change it. So in here, it's an opposite sign, and we don't want it. So what we do is we put a negative, because negative times negative is positive. So negative x squared times negative x would give us a positive x cubed. Then 2 times negative x squared would give you negative 2x squared. And now you'll be saying, okay, now I could probably do a subtraction up here, because both the variables are same, x squared. Okay, before we do that, we need to subtract it. So we put the bracket, put negative, because we never have to forget about the negative, or else it would make the whole question wrong. So now this positive x cubed would change it to negative x cubed, cuts down, and then this negative becomes positive. So now we have positive 2x squared, and the negative 4x would come down. And you'll be saying we should also put the positive 4. No, you never do it. Whenever you do it, you only take down one variable. It doesn't matter how long the equation is, you always pull down only one. So now you're up with a square, right? What times x would give us 2x squared. So that is simply simple. You times 2x times x to get 2x squared. But we have to be careful about the sign, that it has to be positive, right? So to make both things positive, we put opposite sides. So it would be negative 2x, because negative 2x times negative x would give us a positive 2x squared. Because at the end we have to remember about the fact that we have to put a subtraction sign or negative sign at the end. Then so positive 2 times negative 2x would give us negative 4x. You bracket it, we put a negative sign, because we always have to do. And then this negative times 2x squared would cut off, and this negative would become positive. This would also cut off. So now we end up with 0. But remember the fact that we also have 4, so we need to pull that 4 down with just 4. And you'll be saying, like, how are we supposed to do it? Actually, you cannot do it. This is your final answer, so basically it's just 4. So we'll just remove the 0, it's just 4. So remainder is basically 4. It's just 4, and you cannot do it because negative x plus 2 is greater than 4. How? It's because it's one level higher exponent than 4. Because 4 is also 1, but you also have a variable up here, which also has 1, but it's a variable, so it's a higher level. And you'll be saying, how this higher level thing work is basically any number. So let's say 5 number, then a variable, then the exponent, because this is x1, and then x3, x to the power of 3, then x4, and so on. This is what the level is. You cannot divide this. You cannot divide this by this, but you can divide this by this. So you could divide x divided by 5, but you cannot divide 5 by x. You'll be saying, oh wait, we have always seen this thing, and it always works. But in technical terms, when you do a long division, it never works. Even if any other division you do, this would never work, because that is literally not possible. And that's how it works, and you end up with a remainder of 4. This is your again a quotient, and this is our divisor, and of course the end bracket is dividend, because it's always end. Okay, so that's how you would do a negative question. And so let's do one more example, which is a little bit challenging one, and I would say that you guys should try by this by yourself and then go forward in the video, because then only you're testing your skills. Did you understand or not? So the question is 3x to the power of 4 minus 5x squared plus 6x minus 2 divided by x squared minus 1. So this is your question. So just take a minute, or take more than a minute, to solve this question by yourself, and then watch the video, because then only you will understand that. Did you understand? Are you confident about this concept or not? Let's pause the video. Okay, so I would assume that you did yourself and you did get the answer, or you did get the answer and you want to verify that you did it the right way or not. Alright, so let's do this. So we see the numerator, or the dividend, and we see that there's a missing term, which is x to the power of 3. So we have to put a 0x to the power of 3 to fill out that space. So it would be x to the power of 4 plus 0x to the power of 3 minus 5x squared plus 6x minus 2 divided by x squared minus 1. And please ignore the tick sound, okay? So now we have this, and we would put in our equation, or whatever you want to say, the power of 4 plus 0x cubed minus 5x squared plus 6x minus 2. And we put x squared minus 1. So this is your basically the thing. So what times some x would give you 3x to the power of 4? Pretty simple. The exponent rule. When you times it, you add the exponents. So 2 plus 2 is 4. So 3x squared times x squared is 3 to the power of x4 minus 3x squared. This is something like, wait, what? Why is it like this? And you'll be saying that, yes, we also have a missing term up here as well, which is 0x. We also have to fill in that place in order to solve it, because then this would never work. So let's erase this thing and this as well. Now it will be x squared plus 0x minus 1. So we would still put this, and then it would be this plus 0x as x is times 3x is basically 0x cubed minus, now 3x squared would go. And we bracket it and we put a negative sign. And you would be saying that we need all the variables to be negative. Not really. Always focus on the first variable to make it 0. Don't care about other all variable. We'll go step by step. This, then this, then this, then this, and so on. So we put a negative sign. This cancels out. This is negative. That also cancels out. And that negative times negative will become positive. But this is negative. Negative 2x squared. So negative 5x squared plus 3x squared is negative 2x squared. So then we pull up this. So we put plus 6. Right? And then what times x squared gives us minus 2x squared? That is positive. Why? Positive. Positive or negative? Huh? You put the sign that is in there. This is negative. You put negative. So negative 2. And negative 2 is negative 2x squared. And then this would be still 0. And we would say, hey, wait. You never said this would go up here. We also pulled this. Yes. Because it depends what the thing the divisor is, and then you would solve it accordingly. So this, because it's 3 terms, you would go 3 terms, you would down by 3 terms. So now that this becomes 0, and then you negative times negative, this is positive 2. Do this. We never forget about our negative. Negative, positive, that cuts down. Positive, negative, but it's just 6x, and 0 minus 0x is just 6x. And this becomes negative 2, minus negative 2 is negative 4. So this is our reminder. Actually, not reminder. I'm writing this wrong. It's not reminder. It's remainder. Yes. You should just realize, okay, it's remainder. Who cares about spelling? Okay, nobody cares about spelling. It's just the fact that you understand it's a remainder. So yep, this is a remainder. This is our question. This is our divisor. Right, and so this is how you would do with this. But the fact that you should also know how to write the final statement. You'll be like, what's the final statement? Final statement, or you could say that it's write a long division statement. Like basically, or you would say a division statement if that term is used or not, right? So because I have been studied on, and I know that it's called division statement. Sometimes your teacher can ask you to solve this by doing long division and also write a division statement, and that also considered as the what do you say in marks, sorry. So division statement would basically be like, okay, your right hand's proof that this is that. No, you would not do this. So what you do is you would write the dividend equals divisor times the quotient plus the remainder. Because we did this all multiplication, we end up with this, but we still have this. You add that, and then only you get the right answer. So for division statement for this question would be our original this So 3x to the power of 4 minus 5x squared 6x squared minus 2 equals. I'm doing this because I don't have much space. Well, why would I say that? Okay, so you have equals or divisor, which was x squared minus 1 times our question that the answer we found is 3x squared minus 2 plus a side remainder, which is 6x minus 4. 6x minus 4. And sometimes teacher also like you to write in the formula statement, because the real formula for this d of x equals di of x times q of x plus r of x. It basically means the same thing, because we are dealing with equation. That's why dealing with equation or functions, we're meant to say in this way. So you could also state this, or remember just this, and just place the values and it would work. Okay, so now, so there's an easier way how you do this, but this only, and it's called synthetic division. But the catch to this is that this only works when this only works with a linear equation. When you are dividing any function with a linear function, with a linear equation. So what this could work is, so for example, an easy one. Let's go not the cube, actually square. Minus 4x plus 4 divided by x minus 2. So one way you could do is you factor this out, you get two things, probably match with the bottom one. We hope so. And we cross multiply it. That's the really basic thing, right? But we don't want to do that, so that's why we're going to change this to a cube. Now you cannot do this because you really don't know how to solve how to factor a cubic function. So synthetic division really works as you only deal with the exponent coefficients. So you would draw this L with a long base, and then you would say that this to 2, and you were saying y2. It's the same idea, and then here the dividend would go right here. Dividend would go, and here of course our divisor would go. Right, the same idea about the fact that the inside will be always dividend and the outside will be always divisor. So now your divisor is x minus 2, and so you could say that x equals 2. That's why we put a 2 up here. Now we put the coefficients, as I said before, in the bracket. So this is 1. We have a missing term. You have to remember the fact that the missing term can be there just to trick you and make the question wrong. So because the missing term would be 0x squared, because x cubed x is x squared, would be 0. We would just put 0. Then we have negative 4. We put negative 4 and this 4. And you were saying that what's the relation between each other? There's no relation between each other. There's no pluses. There's no minus between 0 minus 4 or minus 4 plus 4. They are all individuals for now. So now what you do is you pull down the first one. This is a common rule. You pull out the first one down. It's just 1. You say 2 times. You times this number. You always times the bottom one, and so that you go up. So 2 times 1 is just 2, and you have this. Now what you do is when you have this, you subtract the top number with the bottom number. So 0, 2. So it's basically 0 minus 2. You have to imagine the fact that there's a negative always up there that changes your number. Not negative, actually, let me take my words back. You always add or you subtract. It really doesn't matter. You always add. So 0 plus 2 is 0. 2 times 2 is 4. And you're saying minus 4 plus 4, 0. Right? 2 times 0 is 0. So put 0 and the remainder is 4. Right? So that's how you really do synthetic division. And I'm saying like, this really doesn't make sense. Actually, it never really does. So the thing is, this is your remainder, okay? So you leave this because this will all goes to 0. You learned this one, the fact that there will be a graph. So you forget about the remainder and you end up with these three things. So you have to place the variables. So you would say, so you would go in order. Number, x, x squared, x cubed, and so on. Okay, so here you have 0, so which is 0 plus 2, which is 2x. If it's a negative, you put a negative 2x. Simple as that. And then you would do this, which is x squared. And because, so that basically is your question. So let's to simplify this, it's just x squared plus 2x. Because we don't care about the 0, and if you want to simplify it, you can alter it in this way. You take out the x, just this common factor, and you're going to end up with this. That's how you solve. That's your answer. Simple as that. And if you want to say a division statement, you would simply state that it's x cubed minus 4x squared minus, sorry, this 4x. Minus 4 equals x times, that's why it's better to write in this one and not in this one. You just say x plus 2x bracket x minus 2 plus 4. That's your answer. Easy as that. Let's do another example. So another example is 2x cubed minus 3x squared plus 4 divided by x plus 1. That's your question. And I would suggest that you pause the video and do this by yourself to gain confidence. Okay, I give you a minute so, and then let's just do this. So if we would do this, we make L base L array, and then x plus 1, so x equals -1. We put a -1 up here. The coefficient for this is 2. Then our x squared, so -3. Missing term, 0x is 0, and then 4. We pull down this as we always do. -1 times 2 is -2. -2 plus -3 is -5. -1 times -5 is just 5. Oops. It's just 5. It's just 5. 5 plus 0 is just 5. That is -5. That comes from -1. This is your remainder r. We have this, like as I said, this is plus 5, -5x, because you go up, and this will be 2x squared. And this, you were saying this is your final answer. Not really. You could say this is your question, of course, but teachers would like you to simplify this and get the actual numbers. So what you basically do, you just do factoring. So 2 times 10, because a value is not that. You have 10. That is basically 2 times 5. What do I go? Whoa. Why is it not working? You can't really, in a way, wait, this doesn't work. So what you do is you do the discriminant, which is 2x squared minus 4ac. Yeah, you always need the fact that quadratic quotient would come up. So that is 25, because 5 times 5 squared is 25, or 2ac5. That's 10, -40 times 25, a negative number. And when there's a negative number, you don't have no real roots. Simple as that. So now you could just state this as your question in your division statement. So let's also state our division statement actually. So 2x cubed minus 3x squared plus 4 equals 2x squared minus 4x minus 5x plus 5 times x plus 1 plus -x. You could also say just -1. So yeah, that's your division statement. Then let's do a tougher one like we did for the division statement. So a tougher one would basically means so a tougher one would be this: 5x to the power 4 minus 3x cubed plus 2x squared plus x plus 7 divided by x minus 2. This is your tougher one, and I would just start explaining because this is a tougher one. I don't think you would get it, and if you think you would get it, you're that confident, just do it right now and say the answer in the comment section and see if you get it right or not. So boom, boom. So that's x equals 2, 5, negative 3, 2, 1, 7. Easy. Then you would pull down that. That's 10 minus 3 plus 7 is 7. Plus 10 is 7. 2 times 7 is 14. That's 16. That's 32. 32 plus 33. 33 times 66. 66 plus 7 is 73. So yeah, you would say this goes to 0. You forget about this. You technically don't forget about this. You have to remember the fact that this is there. But in grade 12 function, you would usually don't care about the remainder. So you just leave that. Don't care about it. So now we have 4 terms. 5, 7, 16, 33. So this is your numbers same. X squared, x cubed. So it's 5x cubed plus 7x squared plus 16x plus 33. And you'll be saying that I don't know how to solve this. Then what you really do is just keep it. You can make it as just this is your answer. This is your answer. Simple as that. There's a bit more step as well. You would do some other common factoring and things, but we'll talk about this in the next video. For now, this is how you do a synthetic division. And that's it for this video. Thank you for watching. Please like, share, and subscribe. I'll see you guys in the next video. Bye-bye.